Hello friends, I am Banthiya from Banthiya's Training and Consultancy, and we are looking at mole concept and stoichiometry. Today we are gonna see couple of numericals based on mole concept and Avogadro's law. Before that, if you haven't seen previous sessions which talks about some basics of Gay-Lussac's law and mole concept and Avogadro's law, please find the link above. Let's start. So the first numerical is calculate the mass of 2.8 liters of CO2 where carbon is 12, oxygen is 16, all measures at s.t.p. CO2 will have molecular mass as 12 plus 2 into 16, that will become 12 plus 32, which will become 44. So gram molecular mass will be 44 grams, and as we have already seen, this will occupy 22.4 liters of volume. So the question is, what is the mass occupied by 2.8 liters? And as we already know that this will be at s.t.p, and the question states that everything is at s.t.p. So just cross multiply 44 into 2.8 divided by 22.4. This will give you the desired answer, which comes out to be 5.5 grams, which is your desired answer. Let's see the next numerical. Calculate the volume occupied by 53.5 grams of chlorine, that is Cl2, all measures at s.t.p. Cl2 is 35.5 into 2, which will be 71. Now this 71, when we write it in terms of gram molecular mass, it's 71 grams, and this will occupy 22.4 liters. Now the question is, 53.5 grams will occupy how much? So X will be 22.4 into 53.5 divided by 71, and the answer comes out to be 16.87 liters when you calculate it. That's a very simple basic question. Now let's see the next question. Calculate the number of molecules of 109.5 grams of HCl, all measurements at s.t.p. Gram molecular mass, we can directly write it to be 36.5 grams of HCl, and this will contain 6.02 into 10 raised to 23 molecules. The question is, 109.5 grams will contain how many? Now this is also a very simple mathematical expression, and we can solve it by cross multiplying. So 6.02 into 10 raised to 23 into 109.5 divided by 36.5, and when you simplify this, you will get an answer. 3 into 6.023 into 10 raised to 23 molecules, and that's your final answer in this question. Now let's see the next question. Calculate the number of molecules and atoms in 192 grams sulphur S8, all measures at s.t.p. So S8 is 8 into 32. Here you get 256 grams, that is GMM, and you have been asked the number of atoms and molecules. So the number of molecules will be 6.023 into 10 raised to 23 in this molar mass. So what will you get for 192 grams? X. So X equals to 6.023 into 10 raised to 23 into 192 divided by 256. So when you simplify this, you should get 0.75 into 6.023 into 10 raised to 23, and number of atoms would be x into 8, as one molecule of sulfur contains 8 atoms of sulfur. So this will come 0.75 into 8 into 6.023 into 10 raised to 23, which will come down to 6 into 6.023 into 10 raised to 23 atoms. And this will be your answer to the second bit of this question, and this was your answer for the first bit of the question. Now let's see the next question. Calculate the mass of Na, which will contain 6.023 into 10 raised to 23 atoms. All measures at s.t.p. This question need not to be solved because this is already given. Na is 23 grams, that is gram atomic mass will be 23 grams, and as we know that this will contain 6.023 to 10 raised to 23 atoms as the original form. So the answer will be 23 grams of sodium will contain 6.023 to 10 raised to 23 atoms. I hope guys that you are understanding and solving these numericals with me. Thank you for watching this video, and please like, share and subscribe my channel, and please press the bell icon if you don't want to miss any update from my channel. Thank you.